All right, this unit covers the nutrient group carbohydrates, and carbohydrate is really a generic name that includes sugars, starches, glycogen, fiber, some other molecules as well. If you look at the name carbohydrate, carbo refers to it containing carbon, and hydrate, when you think of hydrate, you think of water, and that's exactly what makes up our carbohydrates: carbon, hydrogen, and oxygen. One unifying theme of all the molecules that are part of the carbohydrate group is that they're made up of those three elements: carbon, hydrogen, and oxygen. And it exists in a 1 to 2 to 1 ratio. For every carbon atom you have 2 atoms of hydrogen and 1 of oxygen. This is important because in the unit on lipids, you see the same elements. You see carbon, hydrogen, and oxygen, but the ratios are slightly different. And this contributes to lipids having more energy. They have a higher ratio of hydrogen than oxygen. So you'll see higher numbers of hydrogen bonding going on with the carbon and fewer amounts of oxygen. So structurally they'll look a little bit different, but elementally they have the same 3 basic elements. We'll see this with proteins as well. They're very structurally different. They have hydrogen, oxygen, and carbon, but with the proteins you'll see nitrogen and some other elements also play a role in the molecular structure. So to stick with just carbohydrates right now, again, they have the 1 to 2 to 1 ratio of carbon to hydrogen to oxygen. And really one thing I want to make sure you understand is that when we say the word carbohydrate, it really is an umbrella name for a large group of molecules. Monosaccharides, disaccharides, refined sugars, complex carbohydrates, refined carbohydrates, all those terms you hear used all refer to this large group of molecules. When you hear the term monosaccharide, mono means one, and saccharide means sugar. So monosaccharides are these single unit sugars such as glucose, fructose, and galactose. Disaccharides, di means two, and saccharide again means sugar. So these are our 2 sugar molecules. Sucrose, lactose, and maltose are examples of disaccharides. These are more of our simple carbohydrates. Lots of times they're called simple sugars because they're not very long chains of individual sugar units. Whereas complex carbohydrates, what most of us think as most of us use the term carbohydrate to describe, those are the polysaccharides. But again, remember the term carbohydrates includes all polysaccharides, monosaccharides, and disaccharides. But typically when we use the term carbohydrate in layman's terms, we're referring to the polysaccharides. And when we use the word sugar or refined carbohydrate, people are typically referring to those mono and disaccharides. Complex carbohydrates, essentially these are very long chains of individual sugars. That's where we get the name poly. Poly means many, and saccharide again means sugar. So many sugars are joined together. And typically these are larger molecules that are found in structural components of cell walls of plants, how plants will store their energy long term in the form of starches. Even we ourselves, we store our sugars in our liver and our muscle as glycogen, which is a polysaccharide. So those are some of the functions of some of those polysaccharides. But just remember, carbohydrates includes all of these. And again, some common simple sugars that you'll see on food labels or in the different types of foods that you eat. Fructose, the name fructose actually means fruit sugar. That's how it translates. So when you think of naturally occurring sugars in your fruit, those are typically fructose. You see those in those sugars in fruits and also in honey as well. Those are naturally occurring sugars. Galactose is a type of sugar in milk. We also see lactose and maltose in milk as well. So those are milk sugars. Glucose is our circulating blood sugar. And so again, most of our other sugars, the simple sugars, get converted by the liver into glucose, which is then used mainly by the brain. It's the main source of nutrition for the brain or energy for the brain. And again, maltose, sucrose, these are disaccharides, which can appear when starch is broken down. Maltose, those two glucose units, it gets broken down. Sucrose is a glucose linked to a fructose. again, a disaccharide. And sucrose is what we typically have for our table sugar today. Comes from sugar beets and sugar cane. And again, lactose is an example of a milk sugar. Some common complex carbohydrates are the polysaccharides. Like I mentioned, glycogen. Glycogen is a complex carbohydrate, and that is how we store our sugars between meals. When we have excess glucose, remember that the pancreas will release insulin to get the cells to take up glucose for metabolism, but excess glucose will then be sent to the liver and the muscles for storage in the form of glycogen until it's needed for later use. Starch is a complex carbohydrate, a way that plants reserve their sugars for when the sun goes down. During the daytime, they conduct photosynthesis. They take light energy and convert it into chemical energy in the bonds of glucose. But what do they do when the sun goes down or when their leaves have been removed? They need to still have a metabolism like the rest of us. So when there is no sun, when they cannot do photosynthesis to make energy, they have to rely on the excess energy stores they made while there was sun and utilize that energy just like we would. They have mitochondria just like we do, and they use cellular respiration processes to break down that glucose from their starch stores. It's interesting, there's some great Discovery Show channels about the business of agriculture and how very quickly different farmers, especially like the sugar beet farmers, when they harvest the sugar beets, how very quickly they work to try and get those plants to the market. Because after they harvest the leaves off and they have the beets in the bin, every second that goes by, they're losing product because those plants are still alive. Those sugar beets are metabolizing their own sugars once the stems and the leaves have been removed to consume them to stay alive. And so with every passing hour, a sugar beet farmer is losing pounds and pounds of product. So they very quickly have to get them to the sugar plant for breakdown and processing. Fiber, again, another complex carbohydrate. When you look at the back of like a Metamucil jar from the grocery store, from the drugstore, on the back of it you'll see, or any sort of fiber supplement, it'll usually say cellulose or hemocellulose or maybe psyllium fiber. Fiber tends to be found in the cell walls of plant structures. Plants differ from animals. I mean, they both have the same basic cell structure. They're both what we call eukaryotic cells. They both have a nucleus. They have mitochondria. But one way that they differ is that plants have a cell wall, and human cells don't have cell walls. Plants rely on that cellular wall structure to help hold them upright. And then you also have woody plant structures, which have much higher levels of different cellulose-type compounds to give them more sturdy, rigid wood material and bark. But even just a green leafy plant has the ability to stand upright because of its cellular wall structure. That is made up of cellulose. That is a fiber that we cannot digest. We don't have the enzymes to break down that complex carbohydrate, so that's what makes up the bulk of our digestive waste. Ruminant animals like cows and deer and goats and the like, they have bacteria in their gut which have the proper enzymes to digest the cellulose. Therefore, this is why cows and deer and horses, this is why they can eat grass and get energy from it and we cannot. So that's why we have ruminant animals and that can process those carbohydrates, and then we can harvest those animals, but we can't harvest those grasses ourselves. Chitin, it looks like chitin, I know, but it's pronounced chitin. This is another form of a carbohydrate, and if you've ever had general biology or remember your 7th grade biology class from long ago when you dissected a crawfish or a crayfish or a lobster, a lot of biology classes will do that. That hard shell on the outside of crustaceans, lobsters, hermit crabs, that is actually a carbohydrate. The exoskeleton of the outside of crustaceans is made up of a substance called chitin, which is got some extra cross-linking in the carbohydrate structure, which makes it extremely rigid. And of course, we, again, don't have the enzymes to break it down. Not only that, do we not have the enzymes to break it down, it could be pretty painful if you tried to eat it. Coming out the other end, if you're eating lobster shells, is not going to feel too good. Not only can we not digest it, but it's such a rigid molecule that it's just, however you swallow it is how it's going to come out the other side. It's very a very tough material, very tightly cross-linked, and that helps create that extra protective coat on the outside of certain crustaceans. So those are some of the major carbohydrates. And here I go into a little bit more detail on each of these. Again, glycogen is how we store our glucose between meals. One neat thing about glycogen is it's a highly branched carbohydrate. And because it's highly branched, it tends to kind of have almost like a sponge-like characteristic. All these little branches create this kind of like meshwork, interlocking meshwork, which physically allows for water to kind of hang out in between all of these branches. And so when you see these crazy diets, lose 10 pounds in 3 days, yeah, you can lose 10 pounds in 3 days, but what pounds are you losing? Typically what these diets are extreme starvation diets. You're not getting nearly enough calories to sustain life, and so you completely deplete your glycogen stores. And when you do that, yeah, you might lose a little weight from fat, maybe a little, but not very much. Most of it is depleted glycogen and the water that used to be held within the glycogen. If you remove the sponge from your liver, if you remove that glycogen sponge from your liver, there's no place for the water to hang out. So you end up losing that extra water store too. And water is very heavy. A gallon of water is like 8-9 pounds. So when you look at the weight that you actually lose on those crazy fad diets, most of what you're losing is just water weight. And we'll talk more about this in other units, but starving yourself of those calories actually slows down your metabolism. When your body is not getting enough of what it needs, it will sense that there's times of stress, and that it goes into kind of this closed down starvation mode where it lowers the rate at which it burns calories. Thus, when you go off this crazy diet, not only do you gain back all the glycogen and the water weight, but typically if you just go back to your old habits, you'll actually gain more weight than you actually weighed before you went on the diet. A lot of you have heard of this before or maybe done it. It's called the yo-yo effect, or the yo-yo dieting, where you lose 20 pounds and then you gain 30, then you lose 30 pounds and you gain 35. There is science behind why that happens. It's not just your poor willpower or your inability to lose weight. There is science in the fact that when you go on these extreme diets for short periods of time, you crater your metabolism, and even just going back to your old ways is going to result in more gain of weight than just even maintaining. So keep that in mind when you get suckered into those crazy plans. That the bulk of that weight loss is just water in those few days. Again, I mentioned that glycogen is stored in the liver and the muscle. The liver really is responsible for regulating the blood glucose. So they build up and break down glycogen based on the need of the blood sugar level. Whereas muscle is really more of a geography issue. When you have quick bursts of energy that you need if you're going to sprint or do some strenuous exercise, it takes too long to have all those signals go to the liver and then have the liver to break down the glycogen and have it circulate to the muscle. So it's really a location issue. If you have a little glycogen in your muscle, you've already got your energy stored right there. Not a lot of it stored there, but there is some stored there for just quick breakdown and quick use. And a little tiny bit in the brain, not very much. But again, glucose is the fuel of choice of the brain, so having a little glycogen nearby doesn't hurt. Starch, again, I mentioned earlier, plants will take water and carbon dioxide, and with the help of some sunlight, they'll convert the sun energy, the light energy, into the chemical bonds essentially between the water and the carbon dioxide, and form that into glucose. Then those glucose individual units are chained together and stored as starch for long-term use and for when the sun's behind clouds or it's gone down for the night. We obviously eat starch. Every time you eat a potato or different grains, we can digest starch easily into glucose and essentially obtain that stored sun energy from the plant. So anytime you eat plant material, a lot of the plants where we eat the root structure, like the potato, some of the stem structures, I'm trying to think, like rhubarb, lots of beans, legumes, different seed structures. Plants will store them in different ways in different parts of their structure. But anytime you're consuming a plant and getting nutrition, the energy yielding nutrients from that plant, ultimately you're getting the energy from that plant from the sun. It's an indirect way of getting sunlight energy. Therefore, we all depend on the sun. It's not just the plants. If plants didn't have sun, we would lose our food source, or the animals that we consume would lose their food source. So ultimately, we all rely on the sun for energy. Again, I've mentioned fiber before. A lot of the structural components of plants. These are seed coatings, the hull of the plant, the parts of the cell wall, the stringy part of the celery, the grainy part when you bite into a pear. Those are all forms of fiber. There's two major groupings of fiber. One is called the soluble fiber, and one is the insoluble fiber. And just like the names say, the insoluble fiber, they're not soluble in water. They cannot dissolve in water. These are typically found on seed coatings, the peel of an apple. When you wash an apple, you can see the water beads off of it. That's because the peel of an apple has insoluble fibers in it. So that helps to protect the plant, helps to protect the seeds. And this really makes up the bulk of the waste of our digestive system and helps prevent constipation. The soluble fibers, oops, sorry, 1 second. Whoops, something popped on there, sorry about that. The soluble fibers, just like the name says, soluble fibers, they can dissolve in water, and this would be like the fleshy part of the apple or the fleshy part of the pear. Soluble fibers, since they can dissolve in water, they will enter our bloodstream. And the advantage of these, or one of the major functions of these fibers, is that they have the ability to bind to cholesterol. And so when you hear about a diet high in fiber can help lower your risk of heart disease, this is where that comes from. It's very true. And having a diet high in fiber doesn't just reduce your chances of colon cancer, but it can lower your risk of certain cardiovascular diseases, because we know that cholesterol can clog your arteries, can build up the plaques in your arteries, cause atherosclerosis, increase high blood pressure, can block coronary arteries. And the soluble fibers have the ability to circulate in your blood and help bind up that cholesterol and take it back to the liver for recycling. So that's one of the functions of the soluble. And I like this chart. Again, don't feel like you have to memorize this chart. Some of these charts are just nice little guides to kind of give you a summary of different substances. And I like this one because it breaks it down into the soluble fibers versus the insoluble fibers, and a lot of the common names. Again, if you ever in the store, in the drugstore section of Walgreens or Target or wherever you shop, look at the Metamucils, look at the different fiber supplements, read the back of them, and you'll see a lot of these names. And then here, of course, these are the different food sources. You can see lots of whole grains, legumes, again, those are beans, oat bran, barley, wheat bran, some fruits, especially if you eat the peel of the fruit, you get more fiber that way. And then over here it has some of those health benefits. Diverticulosis, also called diverticulitis. Diverticulitis refers specifically to the inflammation. Diverticulosis refers to the condition, I guess, or the disease. This is where there's little outpocketings of the digestive system. The intestines will lose their elasticity, and part of them will expand and not contract again, and it creates these little outpocketings where the food that you're processing can get stuck and create an abscess. So again, if you have this fiber in your diet, it softens the food as it's going through. It makes the food much more palatable for your system, and it makes it less likely that you're going to have hard stools that would push against that elastic intestine and damage it in some ways. So that's what diverticulosis or diverticulitis is. So it helps reduce the chances of that. And again, I mentioned earlier, we don't have the right enzymes to break down those fibers. That's why we pass them through our system and they make up feces. Same thing with the chitin I mentioned. You don't don't eat it because it will hurt. So you don't want to use chitin as a source of a fiber-like material because your body will pass it as waste, but it's not going to, it'll do more damage on the way through than it will help. So that's kind of a summary of all the major carbohydrates, the simple sugars or the simple carbohydrates, and the more complex carbohydrates. So know those examples and know the sources of those and how they some of their major functions. And here I kind of highlight some of those major functions. Carbohydrates are really probably our first energy choice. I mentioned earlier that proteins, carbohydrates, and fats can all be broken down for energy, but really carbohydrates are our fuel of choice, and glucose is that major fuel of choice for our central nervous system, the CNS. If the brain is starving or without a fuel of glucose, it will metabolize fats, but it definitely prefers to use glucose as a fuel of choice. Glycogen helps to maintain those glucose levels. Fiber helps create the bulk of our waste. And then to keep it really simple, if you go on in science or go on in nutrition and take some more advanced biochemistry courses, this will come up again. But just to keep it kind of simple, carbohydrates, they actually assist in fat burning. There are a couple metabolic pathways where if you have the presence of carbohydrates, they actually stimulate certain metabolic pathways that really kind of fuel the flame of burning fat. And I don't want to get into it at this level any more than that, but essentially, if you want to effectively burn fat, you need to have some carbohydrates around. They help to stimulate some of those fat burning pathways. And again, if you go on in science and biochemistry, you'll learn a little bit more about those. But just for now at this level, know that they are important to, if you want to burn fat, you have to have some carbohydrates around. So a lot of people think, well, if I just starve myself of carbohydrates, I just don't eat any, then the body will have to use fat. Well, that's true, but again, you put your body in starvation mode and it will slow down the rate at which it consumes calories. It'll lower its metabolism. So yes, it will burn fat, but not nearly at the pace or the rate that you would necessarily like it to. So it does help with that function. And then finally, the last major role I have listed here, not all carbohydrates are used actually for energy. Some of them are used in cellular structures. Oops, I got this spelled wrong here. Glycoproteins, it should be spelled like this, Glyco. I got glyco. Sorry about that. Oops. Should be glycoproteins and glycolipids. The glyco refers to sugar, so sugar proteins and sugar lipids. These are structures that will be found on the surface of our cells, and they allow our cells to identify themselves to each other. When you have a multicellular organism like a human, how does a kidney cell know that it's next to another kidney cell and that they should work together? How does it not know that it's a bacteria or a virus or whatever? They communicate because they have different receptors and ID markers on the surfaces of their cells so that they know who they're supposed to be working with, and your immune system who they're supposed to be attacking. So those glycoproteins and glycolipids are very important in self-identification. In point of fact, I'm sure a lot of you have probably heard of your blood type before. I've got AB blood type, or I've got O blood type, or I'm B negative, I'm O positive. When you hear people talk about their blood type, they're actually talking about the ID markers on the surfaces of their cells. And this is why blood typing is so important. Because if you and I have a different blood type, and I try and give you blood, even though it's human blood, if those glycoproteins and glycolipids are different enough that our blood types don't mesh, your body will identify it as foreign, and that blood transfusion will actually do more harm than good. So very important that we have those ID markers and we match those up properly so that we can identify ourselves. The DRI, Dietary Reference Intakes list, recommends about 45 to 65% of your daily calories come from carbohydrates. So that's a significant amount when you think there's only 3 sources of calories, and upwards of 2/3 of those calories should come from carbohydrates. And this number will vary, again, depending on who you are and how active you are and your age and your gender. So there's a little bit of wiggle room here. It really depends on several other factors as well. But either way you slice it, a significant portion of your daily calorie count should be coming from carbohydrates. So it is really the first of the three energy yielding nutrients. This is the one that accounts for the bulk of our energy in any given day. They also recommend obviously more of the complex carbohydrates and less of the simple sugars. And we'll talk more about that in just a second. So with fiber, American Dietetics Association recommends about 20 to 35 grams of total fiber per day. And this is actually about 2 times higher than what the average person's taking in. So what that means is the average person is not even taking in half as much as they really should be taking in. So again, focus on those whole grains, focus on getting fruits and vegetables in. That makes it a lot easier to hit your fiber content for the day. And again, I mentioned this, lipids are not the first choice of fuel for the brain. Glucose is what they really want. Lipid breakdown will result in what are called ketone bodies, and there's nothing wrong with ketone bodies. They're very common in the morning. When you urinate first thing in the morning, usually you'll find very high levels of ketone bodies, and that makes sense. Glycogen stores last maybe 4 to 6 hours. So if you sleep an 8 to 10 hour night, it's very likely that your glycogen stores will be quite depleted and that you will have done some fat burning through the night. So you do see it typically higher in the morning, but ketone bodies can also be an indication of other issues, like if you're developing issues with sugar processing or diabetes or things like that. If there's extreme weight loss, even though you're eating a lot of sugary foods, ketone bodies can be higher in people that have certain metabolic disorders. Again, there's nothing wrong with ketone bodies. They are a legitimate byproduct of lipid breakdown, but typically we don't metabolize a high percentage of our lipids as our daily energy source. That's not the major function of our lipids. So now just to talk again a little bit about the fiber. Fiber-rich foods, not only do they provide you that bulk for your digestive system, not only do they help lower your cholesterol, but typically fiber-rich foods also supply a wide variety of vitamins and minerals and phytochemicals. And these foods also contain very low levels of fat. So when you think about, vegetables, fruits, legumes, beans, whole grains, those are very nutrient-dense, nutrient-rich foods, as well as rich in fiber. So again, not only are you not, you're helping to address these issues of the peaks and troughs of your blood glucose and prevent normal blood promote normal blood cholesterol and help with bowel functions. You're also getting a lot of other great nutrition by eating typical fiber-rich foods. Fiber also, because fiber is so bulky and tends to hold water, it gives you more of a full feeling. So it encourages a healthy body weight. It fills you up and keeps you feeling full longer than highly sugary foods do. Also it just promotes overall general health as well as, again, like I said, giving you lots of good other nutrients. Quickly, just how the body processes carbs. We talked about this a little bit in the digestive unit. We start digesting carbs right away in the mouth. Amylase will start to break them down. The small intestine and the stomach will finish any carbohydrate breakdown into the basic mono and disaccharides. Those are easily absorbed into the bloodstream across the small intestine. And then that bloodstream all of that will eventually pass through the liver. And once it gets to the liver, any mono or disaccharides that are not glucose will then be converted to glucose. So those circulating simple sugars, as they transport through the liver, they'll all essentially get converted to glucose. And then that is when they go out to our tissues for metabolism or to the liver and muscle, where they get stored as glycogen for between meals. So to kind of look at this overall process, and I usually recommend to students, take the time to draw this out. Take the time to either diagram this or write it out in essay form, or ask yourself a series of questions and see if you can actually write out the answer. Because if you can write it out in essay form, then you really know it well. What happens when you drink a Mountain Dew? What happens when you haven't eaten for 4 or 5 hours? What's going on with your blood sugar levels? What's going on with your pancreas? What's going on with your insulin levels? What's going on with your liver? ask yourself about these different circumstances of food consumption, lack of food consumption. What are the different organs of your body doing in processing the carbs, and what do your blood sugar levels look like? So just to kind of run through it briefly for you, and again, I highly recommend practicing writing this out yourself because it's not something that's easy to memorize, because it's a process and it's always changing. Your body's trying to keep this constant level of homeostasis, this internal balance, but we're constantly consuming things or not consuming things, or exercising, not exercising, and the body is working within those parameters to try and maintain that internal balance. So step by step here, let's run through this. So what happens when you consume a sugary donut and a Coke for breakfast? Your blood glucose levels rise rather quickly. Simple sugars don't need to be processed any farther. All they need to do is get absorbed across the intestinal wall. And once that happens, you're going to have high levels of sugar floating around. The pancreas will sense that and release insulin. And this will signal the body cells to take up glucose. So insulin is the key that unlocks the door to get glucose inside the cells. So when that blood concentration drops and the cells need energy, the pancreas will produce glucagon. And this signals enzymes in the liver to break down the stored glycogen and then release it into the blood as glucose. So if you just consumed a sugary donut, you're going to see high levels of glucose floating around, and insulin is going to encourage them to be uptaken by the cells and the excess to go get stored as glycogen. If it's been 4 or 5 hours since you've eaten, well, really even just 2 or 3 hours, you'll start to see glucagon getting released, and you'll start to see glycogen get broken down as glucose. So consuming high levels of simple sugars really puts a strain on the pancreas's ability to regulate those blood sugars. Since they're so quickly absorbed, it's got to respond quickly and dramatically all the time when you're doing that. Again, over time, this will put enough strain on the pancreas that you can develop diabetes. Diabetes mellitus, that's the fancy full name for what diabetes is. Again, there's a couple different types. First of all, diabetes is a disease that results from either no insulin production or the ability of the cells to respond to insulin, or the inability of the pancreas to make enough. There's 2 major types. Type 1 is a genetic disorder. Used to be called juvenile diabetes because that's when it would be diagnosed. The pancreas just can't produce any insulin. There's a genetic deformity or a genetic mutation in the insulin gene, so that the body can't make insulin protein properly. So when it makes the insulin, it doesn't function the way it's supposed to. Used to be called juvenile diabetes because that's when it was diagnosed. People would find out about it when they were a young child. But now we just really try and call it type 1 because type 2, sadly, is becoming more and more common in kids. So it's misleading to call it juvenile diabetes. By far and away, type 2 diabetes is the most common. Tens of millions of people have it. My last data showed well over 16 million, but I believe that number is off. It's probably well over 20 million now. Again, don't worry so much about numbers. They're always changing, but have a sense of that type 2 is by far and away the most common type of diabetes. It's preventable. It has to do with habits and diet and the environment, and it's unfortunately growing at exponential rates. Used to be called late onset diabetes, but since, again, it's been occurring in younger and younger people, 12, 13 years old, they're getting diagnosed with diabetes or even pre-diabetes. This is causing huge problems on quality and length of life. Kids that are diagnosed as pre-diabetic by the age of 11 or 12, on average, are going to lose 17 years off their average life expectancy. That is an astounding number, to think that getting diabetes or being pre-diabetic at this young of an age can have that great of an impact on how long you're going to live. But statistically, that's what we're seeing. We're seeing that 17 years has been cut off of the lives of these children on average who develop these conditions. Gestational diabetes. Gestational diabetes only occurs during pregnancy. It's more common in women who start out overweight or who have already had a previous pregnancy with a large baby. And again, it can cause multiple challenges as well as very large babies. If this isn't managed well, if you're not able to regulate your sugars, they cross the pancreas and that baby just gobbles them up and grows like a mad child. And you see babies 12, 13 pounds, 14 pounds in women who have gestational diabetes. So very dangerous. You're not going to be able to birth them normally. And you could have issues with preeclampsia, which is high blood pressure, and other problems. So, but again, the cure for gestational diabetes is having the baby. Once you get the baby out, it goes away, or it should go away. But the best thing to do, is just not start your pregnancy overweight, and really just, again, watch how many simple sugars you're consuming in your diet, just like anyone else, anyone who isn't necessarily pregnant. Why diabetes is such an issue? Again, I already mentioned that you have a shortened length of life on average. We see so many other complications too. The quality of life goes way down. People with diabetes struggle with lack of nerve sensation in their extremities, damaged capillary beds at the tips of their fingers and toes, which makes it hard to feel pain. So you're more likely to stub a toe or to get an ulcer on your skin that just won't heal. So with this damage in circulation, it's really hard to get wounds to heal. It's hard to feel things. You're more likely to lose a limb. Heart disease, kidney disease, again, premature death. Higher risks of different diseases such as flu and pneumonia and death from them. So lots of issues that arise with having diabetes. So if you can prevent it, you really should, because in the long run, these issues are going to come up, especially later in life. If you're starting to deal with diabetes in your 20s and 30s, you might be like, oh, I can just take some insulin and just monitor it, and it's fine. But if you can get yourself off that insulin injection just through diet and exercise, if you can manage your diabetes and just get back to a normal, healthy sugar level that you don't need supplements to regulate, you're much less likely to have these issues. Some of the signs, if you're wondering if you have it or if a friend of yours might have it, typically people who are struggling with diabetes, they tend to urinate a lot. They tend to always feel like they have to go to the bathroom. They tend to always feel thirsty. Often a typical sign will be glucose in the urine. That's very common. That's the first thing most doctors will think when they'll check if you're feeling these issues, if you have unforeseen weight loss, so you have any nausea, easy tiring, weakness, irritability, you're always thirsty, they'll check your urine, and if they see glucose in your urine, it's almost always 9 times out of 10 you have diabetes. You might see more infections, you might have vision disturbances. Blindness is another common ailment that we see with people with extreme diabetes. So they'll check all this stuff. They'll check your urine, they'll check your blood if you have some of these warning signs. Hypoglycemia and hyperglycemia, these are a little different than diabetes. They're not really the same pathology, I guess I would say. It's by definition hypoglycemia. Hypo means below. Think of hypothermia. If you're hypothermic, your body temperature is below normal. Hyper means above. So hypoglycemia means low blood glucose concentrations. And there's lots of different things that can cause this. Sure, if you're diabetic, you might run into an insulin overdose, which causes you to be hypoglycemic or something like that. But there are other things that can cause it. Low body weight, just lack of taking in enough nutrients. Typical symptoms include fatigue, weakness, dizziness, rapid heart rate, anxiety. Pretty hard to diagnose this because some people do feel weak or tired or dizzy from a lot of different things. But if you feel these types of symptoms constantly, maybe get your blood sugar checked out. Maybe you have hypoglycemia. Conversely, if you have hyperglycemia, this is where you constantly have high blood glucose concentrations instead of low concentrations. Again, symptoms can be similar. Rapid heartbeat, anxiety, a sense of constant energy. That might be hyperglycemia. But again, both can indicate impending diabetes. If you're starting to have trouble regulating your sugars, if you have pre-diabetic conditions, you can see both of these situations manifest themselves. These symptoms are so vague. That you could have Graves' disease, you could have Hashimoto's disease, There's a lot of different diseases that are linked to rapid heartbeat, anxiety, sense of high energy, cold sweats, hormonal changes. So it's not necessarily these things, but if you are having these and you've been unable to figure it out, see your doctor and just do a simple blood test to get your blood sugars looked at, because it might tell you a little bit more about your metabolism, and it might indicate diabetes coming on. Sugar is everywhere. I just got done telling you why it's not good to eat that sugary donut and Mountain Dew and not have anything for 6 more hours. Those sugars get quickly absorbed and are hard on your pancreas in the long run, but it's really hard to avoid those sugars. And I like this table. Again, I don't expect you to memorize tables and charts, but I like this table because it really shows you all the different names for sugar. These are all examples of different mono and disaccharides, and you will see these on food labels. Dextrose, that's basically a fancy name for glucose. Fructose, galactose, glucose, I mentioned these. Granulated sugar, this is the common table sugar. Honey is a simple sugar, it's a fructose. Brown sugar, confectioner's sugar. Corn syrup, we see corn syrup in everything. High fructose corn syrup, pay attention to your food labels. You will see high fructose corn syrup in tons of foods. This is a very, very common sweetener, and it's very, very hard to avoid when you're eating processed foods. So pay attention to that. Lots of times, I think I mentioned this earlier, if you look at the kids' cereals, the Lucky Charms and the Honeycombs, a lot of them, high fructose corn syrup is either sometimes the first, if not the first, the second or third main ingredient before even the grain. Before even the grain that's been used to make the cereal, you have sugar as the most abundant ingredient. So those are some things to pay attention to. So watch out for these words and just be really conscientious when you're eating processed foods, how much sugar that you're having. A lot of people think, well, if I don't eat fat, I'm not going to get fat. As long as I keep fat out of my diet and just eat carbs, I'll go on one of those high carb, low fat diets and I won't get fat. That is not true. Sugar is just as important at looking at when we look at obesity rates than anything else. And actually, it's probably more linked to obesity than fat is in a way. What we see is that as sugar rates increase, so do obesity rates. Because again, calories in, calories out. When you eat calories in excess, and a lot of those calories come from sugar, that contributes to your body fat stores. If your body has excess sugar that the cells don't need, it will get stored as glycogen. But if there's still more sugar that it doesn't need, there are metabolic pathways that will convert those sugars into fat. So you don't just pee them out. They go somewhere. And if you're peeing out sugar, again, that's a sign of diabetes. That's not a good thing. You're not supposed to have glucose spilling over into your urine. That's a sign of a problem. Excess glucose, if it's not being used and not being stored as glycogen, it will get converted to fat. So low-fat diets aren't enough to stop obesity. You need to control your sugar too. And again, we know that sugar is linked to obesity, aggravating diabetes, increasing heart disease, disrupting behavior in children and adults, dental decay and gum disease. The bacteria that naturally live in your mouth, they just love it when you eat sugary foods because they will metabolize sugars that are left behind in your mouth. And some of their byproducts from their metabolism are very acidic. And those acids eat away at the enamel on your teeth. So making sure you reduce your sugar levels is very important for your gum and tooth health as well. And I would love to just, I realize we're getting better at diagnosing hyperactivity disorders and ADHD in children. But one thing I've also noticed in the last few decades is we're also sugaring the heck out of our kids. And I wonder how much of the diagnosis of ADHD and hyperactivity disorders we could eliminate, and it would go away if we just cut some of the sugar out of our kids' diet. There's no doubt about it. We have all felt the sugar high before, and when you have children who are not good at regulating their ability to control behavior and don't know how to interpret their inhibitions, and they don't know the long-term consequences of their behavior, you're more likely to see them eat with reckless abandon. If you're not monitoring it, they're going to eat whatever they can and indulge themselves, and that can contribute to that kind of hyperactivity. So No doubt about it, high sugar diets are going to result in overactive kids and obesity in kids. Again, high sugar means more calories in your day. So when you think about this the next time you go down the soda pop aisle at the local Walmart or the local Cub Foods or the local Kroger, wherever it is you shop, and just think to yourself, oh, my nutrition teacher told me this. When you go down that soda pop aisle, that whatever beverage aisle, there is nothing in that entire aisle that you need. There's no nutrition there. There might be some bottled water there, which is fine, but bottled water is highly overpriced, and you can get the same thing from a drinking fountain for free. That entire aisle, everything in that aisle is empty calories. Everything is empty calories. And even if it's a diet drink, it has artificial sweeteners, which there's no health benefit to those. And I'll touch on those a little bit more in a second. But if you just cut out the soda pop, the regular soda pop, a couple regular sized cans can be 400 to 500 calories more a day, and you're not getting any more nutrition from that. You're just getting more calories. Do the math. There's about 3,500 calories in 1 pound of fat. So if you're consuming an extra 400 to 500 calories a day that you do not need, and you're not doing the extra exercise to burn it off, that can translate into 52 pounds a year. And you're like, oh, Mary, I drink a couple cans of pop a day and I don't gain that much weight. Sure, but you're probably replacing other calories that you would have eaten that might have been healthier for you and giving you some actual nutrition, or you've increased your exercise level or your energy level. When you felt a little bit of that sugar spike, you were a little bit more active and took the stairs instead of the elevator. You've compensated somewhere for it. You've either cut something healthy out of your diet and not consumed healthier calories, or you've exercised more. I guarantee you, if you just cut a can or two of soda out of your diet every day, you will lose weight. Replace it with water, and doing nothing else different, you will see weight loss. In my face-to-face class, I do this right away. I do the math on the board for the students and show them on the first day of class how many calories they'll save. And I can tell you, every semester, I've had students halfway through the term or at the end of the term tell me, hey, I've lost 8 pounds. Hey, I've lost 10 pounds. I had one student when they turned in their final one semester. After she turned it in, she looked at me and started crying. And she said, all I did was do what you said about the soda, and I cut out the soda of my diet every day. And not only have I saved a ton of money, she goes, I've lost almost 50 pounds in 4 months. And tears just rolled down her face. She goes, I didn't think it could be that easy. I had no idea what I was doing to my body. It was hard at first, but then I got used to drinking water instead of soda, and I saved the pounds. And when she quit drinking the soda, she started feeling better. She started exercising more. She took the stairs instead of the elevator. She did laps around the campus between classes. Little things, little suggestions I make during class, or little tips of the week that I post on the message boards. She would do those things, and she lost a tremendous amount of weight. And so again, it's not big things that got you where you were. If you're not happy with your health, if you're not happy with your weight, you didn't get there overnight. It took many, many years, or at least months, of little bad habits. So if you want to get back to a good place, it's going to take, a little bit of time with some just small little changes. It doesn't have to be major, major changes. Just look for these little tiny changes you can make. And be consistent with them. Do them for long periods of time. Drink a glass of water instead of a pop. Skip dessert. If you're going to go out to eat with a friend, split the hamburger at the restaurant. Order the side salad instead of the French fries. All these little things add up over time and will make your health better and also make your wallet better too. Overweight kids increase their risk of becoming obese by 60% with each additional soda they consume per day. The level of obesity in children who drink regular soda is astounding. Basically, kids who have soda every day are overweight or obese. It's almost, unless they have some crazy metabolism and are playing 5 different sports, drinking regular soda is indicative of obesity and being overweight in children. So cut out all of that soda. You don't need those calories. You don't need that expense. It's terrible for you. So again, how do we combat this? The answer to all this, excuse me, make as many of your carbs the complex type. Try to include as much fiber as possible, complex carbohydrates. Even the more starchy foods are better than these simple carbohydrates. So try to eat 5 to 6 meals a day. And my students always say, "What? 5 to 6 meals a day?" It sounds crazy, but that's what I mean. And when I say a meal, I don't mean a steak and mashed potatoes and gravy and a side salad and a glass of milk. And I'm not talking about some 800 calorie monstrous sit down dinner. I'm talking about little 200 to 300 calorie meals, or what most people think is a snack. Have a whole wheat peanut butter sandwich on whole wheat bread with a glass of skim milk for lunch, and then pack in your bag an apple and a banana, or a little snack bag of carrots, and then have that between classes. Do your best to eat every 2 to 3 hours, about 200 to 300 calories at a time, and make as many of those carbohydrates a complex type. They take longer to digest, they take longer to chop up and break down, so they're assimilated into your body at a slower rate. So you don't get this huge sugar rush into your vessels right away. So the pancreas doesn't have to work as hard to get those sugar levels back down. So slowly absorb your carbohydrates by eating more complex carbohydrates. Fiber, too, is really bulky, so it slows the rate of absorption. And by eating every 2 to 3 hours, you don't deplete your glycogen stores all the way down to nothing and make your body think it's starving. Most of you know, and we've all experienced this, if you haven't eaten for 4 to 6 hours, you start to notice it. You start to feel hungry. You start to feel your stomach growl. You start to notice it's hard to concentrate. You start to feel lightheaded. Well, that's because 4 to 6 hours is about as long as your glycogen stores will last. And so your body is telling you, hey, we're getting in trouble here. We need some more carbs in our body here. So if you eat every 2 to 3 hours and small amounts, you skip those high peaks and those low troughs of spiking the blood sugar and then cratering it out. So where do you find these? I mentioned some of these already, but we'll hit them again. Some of the best sources for carbohydrates are your grains. When you look at your wheat and your barley, your rye, your oats, your corns, lots of the starchy things, potatoes, the starchy vegetables, those grainy things have lots and lots of carbohydrates. So your cereals, your breads, your flours, those are all very, very high in carbohydrates. Whole grains are best. So if you can cook with whole grain flour, try to find the whole wheat breads. And a rule of thumb with the breads, bread labeling is very confusing. I've noticed that when you look at a bread, some of them will say whole grain, some will say whole grain wheat, some will say whole wheat, some will say whole grain white bread. It's very confusing. And typically, the white breads are not whole grain. Typically, they're not. But just because they say whole wheat does not mean that they're whole grain. So what I tell students to do is to look at the food label. If one serving of that bread hits at least the double-digit percentage for your fiber need for the day, chances are it probably is a whole grain. If you look at the side of it, if it says whole wheat bread, and you go and you look at a serving size as whatever, a slice or 2 slices, whatever the serving size is, and it says there's only 4% of your daily allowance of fiber, chances are it's probably not a whole grain. Sometimes they'll say 4 or 6%, but if it says one serving has 10%, even 12% of your daily allowance of fiber, that bread is probably a whole grain bread then. And again, those labels are really confusing. And I know there's been a little bit of, I've actually read some articles where the USDA, the FDA have tried to come down on manufacturers a little bit because they're so confusing on how they label their grains. Typically though, if it says whole grain, it should be whole grain. But look at that fiber content. That will kind of help you. If that fiber percentage is in double digits, it's probably a whole grain. Excuse me. One nice thing too about a lot of the whole grains, the whole grain wheats and stuff, a lot of them will be enriched with other vitamins too, so you'll get some other good nutrients from it. Vegetables, of course, vegetables are very high in carbohydrates. They'll have a lot of dietary starch and fiber as well, so vegetables are a great source. Some of the non-starchy vegetables don't have as much carbohydrates, but they'll have a lot of fiber, which is good for you as well, and a lot of vitamins and minerals. Again, I mentioned like the potato. That's a very starchy vegetable. Fruits, mostly fruits are simple sugars. They're a good source of carbohydrates, but it's more the simple carbohydrates. However, I do recommend consuming those because even though they're simple sugars and they get absorbed quickly, they often travel with a lot of fiber. So when you eat an apple, you're not eating you're not eating a food that's been highly processed, so you're getting a lot of the natural gums and pectins and fiber and of course those vitamins and minerals. So even though it is a simple sugar source, and I just got done telling you don't have too many simple sugars, the ratio of simple sugars to the other good nutrition you're getting, the fiber, the minerals, the vitamins, the good outweighs the bad. Let's put it that way. Versus drinking apple juice, where all the fiber has been stripped away, all the pectins have been stripped away, all the peel has been stripped away, and then they've added high fructose corn syrup. You're getting way more simple sugars with the apple juice than you should. Better to eat the apple, better to eat the pear, eat the banana. Those are good ways to get carbohydrates. Those are good ways to get those simple sugars. Surprisingly to a lot of people, dairy products also do have a lot of simple sugars as well. There's a lot of milk sugar. Maltose and lactose are examples of milk sugar. We don't really see complex carbohydrates in our dairy products. It's really just the milk sugars, the simple sugars. But you also get a lot of protein, you get a lot of vitamins and minerals. You get, a lot of times they're fortified with vitamin A and D. A lot of the milks are calcium, some iron. So you do see a lot of other good nutrition too with those dairy products. So kind of in descending order there, from grains to vegetables, fruits, and then the dairy products. That's where you get, grains are where you're going to see the most carbohydrates. The dairy is going to be where you see the least. And the last category here, really, with the exception of nuts and beans are actually very good sources of complex carbohydrates and fiber. But really, the meat, poultry group, it's not a good source of carbohydrates in general. It's, some students will say, well, wait a second, didn't you just say we store glycogen in our muscle? So when we eat a cow, aren't we getting some of their glycogen, which is a carbohydrate? No, glycogen, when you harvest a cow, when you process cow meat or whatever meat you're eating, it's not a very stable molecule. So when that animal has been harvested, the glycogen breaks down pretty quickly. And so there's not really a good source of carbohydrates when you're looking at meat. Meat is a much better source of protein and iron. But again, dry nuts, beans, legumes, those kind of get grouped in this category, and they do tend to be good sources of carbohydrates, probably closer really to the grains as far as the types of carbs you get. So that's kind of a synopsis of the types of foods you can look at to get your carbs. My last slide that I wanted to run over was on artificial sweeteners. There's a lot of concern over artificial sweeteners, and rightly so. I think it's anytime we put anything artificial in our food, I think we need to be educated about it and be aware of it. So it's good to educate ourselves on what these are and what they mean for our health. Artificial sweeteners are highly scrutinized by the FDA, the Food and Drug Administration. Lots of clinical trials, and the ones that are approved for market have not shown any statistical evidence of cancers. That being said, if you have this concern, don't consume stuff that has artificial sweeteners in it. You can avoid artificial sweeteners. You don't have to consume these types of foods. And this is one of the reasons why really Diet Coke is just as bad for you as regular Coke. Some nutritionists say it's worse. Just because it doesn't have calories, it has artificial sweeteners, it has caffeine, it has phosphates, which help leach calcium out of your bones. Caffeine dehydrates you, which lowers your metabolism. So drinking a diet soda isn't necessarily going to help you lose weight just because you're not eating the extra calories or consuming those extra calories. But if you're really struggling with your weight, if you're morbidly obese or even just obese and overweight, if you fall in those categories and you have a really hard time controlling your trigger for wanting that sweet taste, artificial sweeteners might be the way for you to go. The benefits of having an artificial sweetener might outweigh the risks if you're really struggling to keep the sugar out of your diet. If sugar is really putting you in that obese category, you've got a lot of health risks just being obese. So not necessarily, again, it's picking the lesser of two evils, but just be aware that, we're always seeing new additions to the market. But one thing I think is important to note is not curing the obesity epidemic. The more and more we see artificial sweeteners come out, the higher and higher weights seem to go. So it's not really dealing with the fundamental issue of how we eat. So keep that in mind when you think, well, I'm going to just use some Splenda, and now I'm going to drop this extra 200 pounds. It doesn't work that way. There's a lot of things that influence our overall diet and health, and just replacing sugar with artificial sweeteners isn't going to do it. Common examples of sweeteners, a lot of you have probably heard of these. I think there's a couple new ones out now. My list is always having to be updated, but these are the big four that I've seen in the market a lot, and I get the most questions about. Aspartame, or aspartame, I've heard it said too. That's like your Equal. Equal is the brand name. What it's composed of is it's composed of two amino acids. Amino acids are the building blocks of protein, and those amino acids are phenylalanine and aspartic acid. And what happens is when we consume these, they give off a sweet taste, but they're not a sugar. They're amino acids, and so we don't confer the calories from those. It can cause problems for people that have what's called phenylketonuria. If you look at the back of your diet soda label, you'll see this. It'll say phenylketonurics contains phenylalanine. So look at your Diet Coke label next time and see that it says that, because anything that's artificially sweetened with aspartame will have a PKU warning. People with PKU don't have the ability to process phenylalanine very well, and so consuming these high levels of excess phenylalanine make it very difficult for them to get rid of it. And so they can suffer from terrible nausea, gut pain, vomiting. So consuming lots of aspartame will cause issues for people with PKU. Saccharin, the brand name for it, Sweet and Low. These are the little pink packets. There's been some evidence of increased chances of bladder cancer in mice and rats. But again, nothing statistically significant enough for them to pull it off the market. And the dosage levels that they give it to mice are much higher than the average person takes it in. But that's something to think about when consuming that. Splenda, which I believe those are the yellow packets nowadays. So Equal's the blue, Sweet and Low is the pink or the red, like light red, and then Splenda's the blue, the yellow packets. That's actually sucralose. Sucralose is a sweet-tasting molecule. Our body interprets it as sweet, but we don't have the enzymes to break it down for energy. And again, if we can't break it down, we can't get calories from it. So it confers a sweet taste, but it doesn't give us calories. And Truvia is the same way. It's stevia, is the compound name, and the brand name is Truvia. This is a product made from natural plant compounds, again, that confers a sweet taste, but we don't have the ability to metabolize it for energy. So we don't pay the price for the extra calories in our diet. So again, artificial sweeteners, are they good? Are they bad? They are what they are. It is what it is. If it really helps you with controlling weight and you struggle with obesity or obesity-related illnesses or diabetes, knock yourself out, use them. But again, like I said, the advent of all of these sweeteners has not reduced the obesity epidemic as a whole. So we need to look more at our overall diet habits, our overall exercise habits, when we eat, why we eat, what other things are we doing to our body that artificial sweeteners just can't cure. So very important to pay attention to not just the sugars that we eat, but where those sugars are coming from and what sorts of things we're trying to replace them with. It's not just as simple as saying I'm going to cut the sugar out or I'm going to cut the fat out. It's everything. It's all of our diet and exercise. So keep these in mind as you're planning your diet. Try to get those whole grains in there. Try to eat lots of vegetables. Try and have fruits and vegetables with every meal. Try and pack snacks for between meals. Throw a banana in your backpack. Throw a whole grain peanut butter sandwich in your purse. Try to eat every 2 to 3 hours. Try to consume 200 to 300 calories each time. Drink lots of water. Try and drink at least 6 to 8 glasses. Instead of reaching for the pop, go drink a little bit of water first and see if that quenches your thirst. All of those little things will help with your overall diet and health.